Hello Year 9s, this is lesson 3 and we're looking at polymers. Okay, so now polymer is kind of it's a plastic and it's been in production, especially consumer products, from about the 1950s. And the reason for its popularity is that you can colour it, you can shape it easily and form it, and it's cheap and versatile to use. So it's a great product to use instead of glass, for instance, which is heavy. If you have a milk bottle that's got a glass bottle on it, it's a lot heavier than if it's made from plastic. Alright. Now, polymers are made from crude oil, so it means it is a fossil fuel and it's a finite fuel that's used to create it. So it's refined from crude oil and turned into different products, and one of them happens to be plastics and polymers. And because it's a finite product, that means that we are going to run out of it eventually. So fossil fuels are being used less now for resources because there's less of them. We do have different versions of polymers now. We've got things like potato starch, which is a reusable, a sustainable version, which is far more better for the environment, and it's also something, like I said, we can replace when we've used. Now we're going to look at thermal forming polymers first, and the rule is that they are able to be reformed. So the clue is in the name. It's got the word forming in it, which means it can be formed again, it can be reused, and importantly, thermoforming polymers can be recycled. Okay, so you can change the shape various different ways. If you don't like what you've got, you can go back and reheat it and change it, and it takes a while for the molecules to deteriorate enough for you not to be able to do that. So you have plenty of chances to do it before it does actually undergo a significant change and won't let you do it anymore. Alright. The reason for that is the bonds between the molecules are quite weak, and therefore they're easy to be pulled apart and reshaped. So if you think about that, it's a weak link that's easy to pull apart, reformed. When the heat hits it, it will mould back down again, and you can reshape it. Okay, and you can see at the bottom we've got like typical sort of thermoforming products: plastic bags, water bottles, children's toys, washing up buckets and washing up bowls and buckets, that kind of thing, are predominantly made from thermoforming polymers. Now you're going to need to know the difference between them, so what it means to be a thermoforming polymer, and also what the different types of thermoforming polymers there are. Now I've picked 4, and what you don't need to worry about is the long names. Okay, don't panic if you can't pronounce them or you find it difficult to remember them. As long as you can remember the short version, like for high impact polystyrene, that's HIPS, that's fine. Okay, what you need to know is what they're used for and what they're good at. Okay, so the first one we've got is acrylic. Okay, so that is got good optical quality, which means it's used in a lot of light fittings, especially if you think about car lights, the headlights and the reflector back, the tail lights. They use acrylic because good optical quality means it allows light through without too much distortion. Okay, bathtubs, they are made from acrylic using an opaque version, so they're not see-through, so there's no issue with light, but it's something which it works perfectly for bathtubs because it's a very light product. Okay, next we've got HIPS. Right, now again, that is something which is used for a wide range of objects. Children's toys, you can see I've got a bit of Lego there. Alright, so it's quite tough. It's got good impact resistance. Now that means that it can take a knock. If you drop it or you stand on it, or it's thrown at a wall or whatever, it's not necessarily going to break. It's not brittle. It's not going to crack. So especially for children's toys, they go through an awful lot of stress. That's great for it. Okay, but it's also used for things like yogurt pots. Again, a yogurt pot, you don't want that cracking and breaking under the smallest amount of pressure. So again, handy for that. Alright, so the things that you need to know about it, obviously, is that it is tough and it's, you know, got good impact resistance. They're two main things that you need to remember. Now, high density polythene differs from the others because it's, again, they all look like they do similar things. The HIPs and the high density polythene look quite similar in a way, but there's just a little bit difference to them. Alright, so this one has got what's called excellent chemical resistance. Now that's important if you were using things like washing up bowls or buckets and pipes. Things might go through there which are maybe got a little bit of chemical erosion in them, such as, you know, if you put in something down a water pipe to clean it, if it's got a chemical in it, it might react with the others. It doesn't react as much with this one, so it's not going to melt. It's not going to start a chemical reaction, start melting and degrading. Alright, so it's important that for things like buckets that might have lots of detergents and other things like that in it, that it has got that chemical resistance. PET, the last one for your thermoforming. Again, this is one that you'll use virtually every day. Alright, so it's tough and it's durable, and it's importantly food safe. Okay, so that allows it to be used for packaging of food, for drinks bottles, and it's also low cost. Like I said to you at the beginning, you know, years ago, drinks, any kind of fluid, even things like bubble baths, would you believe, came in glass bottles. Now, for health and safety reasons, it's a good job they don't now, because if you drop that in the bath, it's extremely dangerous. But also from the point of carrying things around, it's a lot more easier to carry things like a plastic bottle than it is a glass one. Okay, so it's a lot lighter, making it a lot easier, a lot more efficient to use. So we're going to move on to thermosetting polymers now. And a thermosetting polymer, the clue again is in the name, it sets. Okay, once it's set, that's it. You can't reform it, it is done. And because of that, one of the other important things about thermosetting polymers is that generally you cannot recycle them, okay, because they're made into that and you can't mush them down again. Okay, the molecules have bonded and basically the molecular structure's changed because of that, and it can't be remade into the original polymer beforehand. Okay, so once it's formed, that is it. Okay, and that is the main difference, and because of that, it's excellent for things like electrical fittings. You don't want your plug socket, for instance, melting under heat, so it needs to be something that is heat resistant and that doesn't react with heat anymore. So we've got 4 thermosetting polymers to look at. So the first one is epoxy resin. Now you will probably know that as a glue called araldite. Okay, that's the product name. It's not the actual name of the material, but that's sort of the commercial name for it. Okay, and you have two bottles or 2 tubes. You mix the 2 together, creates a chemical reaction, and you get a very strong hard glue from it. Okay, doesn't look like a plastic in that respect because it's fluid, but once those 2 mix together, it becomes hard. Melamine formaldehyde. Now again, you've probably seen this in your kitchens. Your kitchen worktops will probably have some form of melamine on top of it, or if you go for like a picnic or barbecue, outdoor sort of tableware that you might take for a picnic. It's made of, it feels like plastic, but it's quite hard, okay? And it's got that really quite hard, strong feeling to it, and that's what this is. It's not just a normal plastic. This is what it is, and it's very you know, widely used for things like outdoor tableware or children's little plates, something that's not going to break when it drops. Okay, polyester resin. Now polyester resin, I'm just going to read this out to you. Alright, it's brittle but becomes tough when laminated. Now brittle basically means that it can break very easily. Okay, so it sounds like it's not going to be any good, But once it's laminated, so it has layers of glass fibre put on it, which is then sort of glued into it, it becomes a really strong, lightweight, mouldable product. Alright, now you'll see this in things like boats, so they need to be lightweight. They've also got lots of different changes in shape, very difficult to make from pieces of plastic or other materials, but very easy to be moulded into those shapes. So it's excellent for that. Car bodies, dead simple to make for panels, and it's dead sort of, like I said, very lightweight and very mouldable. But it has to be laminated. Alright. Now I think next week I'll put a few videos on to show you these, but I need to get through all of this week because it's quite a lot, and then next week I'll just put a few videos on that we can revisit some of this. Okay, so urea formaldehyde, the last one. Like I said to you before about things needing to be for electrical goods, for instance, that they're not going to melt, this is the one that you would probably see most of your plug sockets and things like that made out of. So it's hard, it's quite stiff, and it is heat resistant. So it's not going to melt if something horrendous happens, like a lightning strike like we're having at the minute. It's not going to melt if you have a surge of electricity. Okay, and it's very important that happens, because you don't want it breaking and sort of falling apart, because that can cause a fire. Toilet seats, I mean, they're quite tough as well. So again, it has a range of uses. And the other one says adhesives. It's used as a glue in MDF. So your medium density fiberboard that you use in year 7. Remember when it had lots of layers glued together? This is what would glue that together. Okay, so it's also used, a bit like the epoxy resin at the top, as a glue. Okay, so finally your fact test task, as it were, for this week is to go through the video that we've just done and try and fill in these missing words. Okay, so polymers are mainly made from blank. This is blank fuel. Now don't get all sort of counting the little dashes. They don't mean anything. Alright, so don't think, oh, it's got 5 letters and it can't be that. They're just gaps. Don't worry about that. Okay, so you've got this task, and then that's on the polymers, the thermoforming, and then you've got the thermal setting as well. Okay, which are there. So if you could write them out and just try and remember them, see if you can remember at least one property and one use of each one, that would be great. Give yourself a little test. You could make yourself a little poster type presentation on them. Try and be creative, because you don't want to get bogged down by too many words. Try and just keep it very simple. So epoxy resin, give me a property and give me a use. Okay, and try and do it in a way that you're going to be able to remember it. Okay, right, next week I shall see you and we'll have a look at some videos of forming. Okay.